All right, so we got something a little bit different today, man. This is my Orbit sprinkler control device. One of the last things I did before I got sick with my heart giving out on me is I installed a sprinkler system in my yard. So I dug all the trenches. I laid and glued all the PVC pipe. I configured and devised a plan for water overlap so that the grass would be properly watered at all time. And I did that because it's way cheaper if you do it yourself and you're willing to put in a little manual effort than it is to pay some folks. Now, I didn't connect it to the city water. What I did was I just connected it to one of the faucets on the outside of the house because I think there's some kind of you have to be careful with city water. You don't want to have any type of back flow that's contaminated into the city water. Anyways, so I just left it connected to the spigot, and it works fine. It works great, man. The problem is though, is my wife went out to water the yard, and she uses her phone because this is a Wi-Fi and a Bluetooth, and she said it wouldn't work. And then when I went out there, I was just getting the message, no AC. So what I did was I bought another one from Lowe's. I installed it, and now I'm going to fix this one so that I have a backup. Because I'm going to tell you a secret. When Mama wants to water the grass, Mama wants to water the grass. You know what I'm saying? So anyways, let's plug this in. All right, so I have it plugged in, and it does nothing. It does not recognize that AC is plugged into it. So we're going to disassemble this, see if there's a fuse blown in here, so that we can hopefully fix it so I can have it as a backup. So, all right, let's see how to disassemble this thing, man. I don't know exactly how to disassemble it, but this is what it looks like on the inside. Oh my, is it clipped in? So we got a CMOS battery. How does that come out of there? It's got like a screw driver on a picture. I don't know if I'm supposed to. Oh. Well, there you go. That's how you do that. So let's take this out. Bro, I can't get it out, man. Well, maybe I gotta pull the spring back. Yeah, whatever. That thing can stay in there. So, oh my. Ooh, there's a reset button. You know what? This might be a boring video. No, that had nothing to do with it. So, there's screws. We got to take that out. Alright, so we need to. So that comes out like that. Alright. So how does this come out? Oh, it's clipped in here like this. Ooh, that. I'm about to break the circuit board. And how does this thing come out of here, dude? See screws. I don't know how to take it apart, man. I don't know how to take it apart. Feeling I'm about to break something. Oh yeah, break this. This has got to come off. How does this come off? How do you get this off? As I suspected, it was just clipped on. Oh, that was a plug. Oh, I get it. I get it. Okay, gotcha. So this is what the assembly looks like. And that looks like some flux, maybe. I don't see anything damaged on here. We've got a few components. This is probably the brains of the outfit. This is the reset button that we were talking about. All right. So now we have got to figure out how to check this. We've got to get this black thing off, I think. I'm about to just rip it. That's what's about to happen. Jiminy Christmas. Oh, that was simple. So this is what I think. So I see. So what you have to do is you have to come in and you have to pry backwards in these little grooves, and it removes the tension on the little clips right there. Okay. All right. So this seems pretty simple. This doesn't seem like it's let's pull this back. I'm guessing we should be getting what, DC voltage, or I'm not sure if we're going to get DC or AC out of that. So let's plug it in and let's see if we get voltage. All right, so first thing I'm going to do is I'm going to see if we get AC voltage out of here. Saying we're getting 28 volts AC, but is that actually, let's measure DC and see if we get something different. Yeah, no, it's an AC voltage coming out of there. So we're getting voltage out. The question is how much voltage should we get out of there? I'm assuming rectification has to occur if that's AC voltage. Let's go back to AC. We're on AC. Okay. Pull that off. All right. All right, so this is the back of this thing. And so we've got voltage that comes in, and then I'm assuming it's rectified in some way. Well, let's look at the board under the microscope, see if we can understand what is going on. These things correspond to these are controls, because right here are your connections, right? And they correspond to this row of little screws where that's where you put your wires in for your pump, for your individual zones. That's what this is used for, and those all trace back to these, whatever they are right here, MOSFETs or some sort of transistor. I'm not, yeah, Q1, etc. These are not populated, which tells me This is a six zone deal. So, and there are 7 of these MOSFETs. One, I'm assuming, is used for, yeah, I don't know. I don't know what I'm talking about, man. I don't know what I'm talking about. But these are not what I'm worried about. I'm worried about how voltage gets rectified from AC to DC. So I guess maybe I can live dangerously here and plug this in. Let's take this. Let's put that back there. Let's plug this back in real quick. Yeah, it's definitely still saying it's not getting AC. I don't know where a good ground on this thing's at, you know? I don't know where ground is at. Oh, you know what? Maybe this capacitor. So this is the minus side of this capacitor. Are we getting any voltage here? So we've got 38 volts DC on that capacitor. So I'm assuming, so we know kind of that blue thing and that these are for filtering the voltage coming in here. I don't know what this thing is for. I don't know what its role in life is. Maybe it's another filter. It says L2, so it's an inductor. So yeah, it's probably some sort of filter. But we're definitely getting DC voltage across this big filtering cap right here. So then where does that go? So that big capacitor is right here. So yeah. So we're definitely getting voltage. The voltage is being felt. You would think this thing would be fused, you know? Because I'm sure what happened is the voltage, because, you know, we have power outages and, you know, unless, of course, let me add one more piece to this. Yeah, so it looks like 28 volts AC is coming out of there. So I'm gonna just make the assumption that this is good. That's what I'm going to assume. And then I'm gonna assume that we know the voltage is good to this big cap right here, right? And it's a 50 volt, 470 microfarad. That seems like a standard value for filtering caps, because I think I've seen that on other things. And then it goes, so we have a diode here. Is that diode squared away? I assume it will be, but yeah, that's diode. Yeah, that diode's good. So then it comes into, so where's negative at? Negative is on this side. So if I probe in diode mode from the negative side of my battery, that's what I'm going to call ground, and I come to the input of this, So that looks good. I don't know what this is. I'm not sure exactly what this little component is. That's ground. Okay, good, good. That's ground. So we have this output here, which seems okay. Then it goes through this resistor. And that's ground. There's ground on that side of the resistor. Okay, so what is the output of this voltage regulator? The output of this voltage regulator, or this coil, is ground. So I'm going to say that's probably not normal, right? That shouldn't be ground. There should be some sort of... That seems like it's a voltage rail. What about this diode? Is this diode good to go, or it should be open this way? And it's a short. Okay, I definitely know that's not normal. Yeah, so we have a short here. So, what is it that could be shorted? Hopefully it's not that, because that's probably proprietary. That looks like an opto isolator. We know that that one was good. We know that this diode was good. I think it does look like it's got a little heat spot on the top. Okay, so I think what we need to do is maybe we should inject some voltage and see if we see anything getting hot. You know what I'm saying? I think that's maybe what we should do. So we're going to solder a wire to this diode here. All right. Then we need another wire to solder to the negative side of that capacitor, since I know for sure that's ground. All right, so this is my ground. Okay. Now we will connect up our hot. Let me cut on the overhead camera. So we will connect up hot. And we will connect up ground. We will inject 1 volt at 500 milliamps, and we will see what gets hot. Well, it's kind of hot from where I was soldering, I guess, but let's see here. Let's cut the current up some. Let's try 2 volts at 500 milliamps. So we're drawing 195 milliamps. And the voltage dropped to 0.39 volts. Not seeing anything get hot, man. Oh, there we go. Something over here. So is that diode getting hot? So let's pay attention to that diode. No, it's next to the diode. Ah, it's this capacitor right here. Let me show you under the microscope. I think it is this capacitor. Let's put a little dab of alcohol down. I don't know, man. I don't know. Doesn't look like it. But that's what it said was getting hot, man. Right, and what the thermal camera stated. Because there is the, where are we at here? There is where I've got the water, the wire soldered. No, it's right here. What's right? Ugh, Lord have mercy. Let me just put alcohol everywhere, dude. I'll have to freaking figure it out with my. It's almost like that diode is. And it's either that diode or that cap. I don't know. This is thoroughly confusing. It's like it's. I mean, it's like it's the diode, I think. And that's what it looks like, anyways. You guys weren't seeing that. Yeah, it's like it's the diode, man. So let's just take the diode off and see. It seems weird that a diode like that would short, you know. But all right, let's take the diode off and see if the short goes away. Okay. And that was cathode side here. So let's see if the short has been alleviated. Got it in resistance mode. Where's my, it's the negative side? No, this is right here. All right, is it gone? Yes, it is gone. So this capacitor then was indeed shorted. So if I see, that's the craziest thing in the world, man. That thing has 1.3 ohms, dude. Alright, it's crazy. Alright, well, at least we know now I need to find a capacitor to replace that with. I just need to figure out what type it is, I guess. Right. So I'm assuming, and this is me assuming, that this is a 1 amp 60 volt Schottky diode. Because it says B160, and when I type in B160 diode up on the Google, it comes up with like Schottky diodes for sale and all that stuff. So I'm assuming that's what it is. And it just so happens that I have, from my Bojack kit, I have a 1 amp 40 volt Schottky diode. So I am going to use one of these and see what happens. You know, that's what I'm going to do. I'm going to take one of these out. Hopefully we don't burn up anything or kill anybody in the process. Maybe I can make a surface mount component. We'll try that. I think that is on there. So if I check in diode mode, I've got open one way and I have 0.17 volts the other way. So is this thing going to throw a temper tantrum when I put it in there? I don't think so. I don't think so. Okay. We're gonna plug it in and watch for smoke. I didn't see any smoke. Okay. Let's do this. Hey, hey. Bam. Look at that, y'all. It is fixed. And it was a shorted diode. So yeah, so that's how you troubleshoot and repair an Orbit B-Hyve Wi-Fi automatic sprinkler control unit. So I hope you learned something, and I have a backup now for the one that I have on the house right now. So that's awesome, man. I'm glad I got that fixed, and I didn't even have to buy nothing. But I probably will order the correct part just so I can have it. But anyways, I appreciate y'all watching, man. Y'all be good.